Good day, grade 10 science students. Today what we're learning about is how atoms form ions. To do that, we need to know how to do the following. Alright, so if we're going to do this, we have to know, first of all, how to do Bohr-Rutherfords, okay, which we know, that's review. Then we're going to learn how to do something called Lewis structures, which is new. And then we're going to talk about the periodic table again, and we're going to talk about Lewis structures and periodic table as they relate to valence electrons. And finally, we're going to learn about ions. So here we go. So let's go back to the Bohr-Rutherford thing a bit again. So recall, every atom has one electron for each proton in its nucleus. Okay, so when it's neutral, you have the same amount of protons as you do electrons. So the number of protons tells you what element it is. So if we know, and where do we get the number of protons from? Well, if we look at a periodic table and we know the atomic number, that's how many protons you have. So what element has 12 protons? Okay, so we need to look at the periodic table and we look at the smaller number, which is the atomic number. And the atomic number tells us how many protons we have. So we go across till we find 12 and we see that it's magnesium. So magnesium, when it's neutral, which means it has the same amount of pluses as negatives, protons, which are positive, electrons that are negative. When it has 12 protons and 12 electrons, it's neutral. We know that the number of protons tells us what element it is. This one is magnesium. So it's magnesium, just like we said. What we're going to do now is we're going to actually draw the Bohr-Rutherford for magnesium. We're going to figure out how many protons, electrons, and neutrons it has. And then we are going to draw something called the Lewis structure for it, which is really easy. So again, when we look at magnesium, we see magnesium has two numbers. The small number is the number of protons and electrons, 12, and it has a number 24.31, which is the atomic mass. So we're going to use those numbers to do the Bohr-Rutherford. Okay, so let's do the Bohr-Rutherford. Okay, so what we're going to do is we're going to take those two numbers for magnesium to draw our Bohr-Rutherford first. And the first thing that we know is magnesium has two numbers. It had a 12 and 24.31. And this is my mass, which came from my protons plus my neutrons. And this is my protons, and it's also my electrons when it's neutral. Neutral means no charge. So what we're going to do is we're going to draw our Bohr. Okay, so I still have this line here. It shouldn't be here. So we have 12 protons, and when you subtract the two numbers, well, you just round it. So it's just 24. So 24 minus 12 equals 12, because you know that the protons plus the neutrons equals the atomic mass. So if we have 12 here, that means we have to have what? 12 neutrons there. Now we have to draw the actual electrons around there. So what we're going to do quickly is the first shell holds how many? It holds 2, so we half fill, then we pair. Next shell, I don't know why that's happening with that line, guys, sorry. So we then fill up the next shell. So notice I'm half filling it. If it holds 8, then I have to put 4 around before I pair. And then this is my last 2. So this is the Bohr-Rutherford for this diagram. How many valence electrons does it have? Valence electrons are the outermost shell, and you can see it has 2. Okay, so it's got 2 valence electrons. How do we create this and turn this into a Lewis structure? All we do is we don't worry about the protons and electrons. We don't worry about drawing a shell. All we do is we just copy it, like the last 2 electrons. So you just show the valence electrons. So this Lewis structure is just the valence electrons. It's nothing else. And that's it for Lewis structures. So interestingly enough, if we look at the periodic table, if you look at magnesium, it's in group 2. And it turns out that anybody in group 2 is going to have 2 valence electrons in the outermost shell. And you're going to learn when you do your assignment with me, anybody in group 1 is going to have 1 valence electron. So they have different amounts of shells. When you look at the period, this is period 1. It has 1 shell, and hydrogen has 1 valence electrons. Lithium is in period 2, so that means it has 2 shells, and it has 1 valence electron because it's in group 1. Now we skip all these guys in the middle, and you remember instead of calling this 13, I said call it 3. This one's 4, 5, 6, 7, 8. This is group 3. Everybody in this group, 3A, has 3 valence electrons. This one says 14, we're going to say it's 4, it has 4, and so on. 15 has 5, 16 has 6, 17 has 7, and 18, which is actually 8, has 8. Okay? So we can look at the periodic table and we can say how many valence electrons are in each group, okay? And we also can figure out how many shells it has. So for example, phosphorus, 15 right here. How many valence electrons does it have? Well, the answer is 5 because it's in group 15 or group 5, okay? Also, you can say that it has 3 shells because it's in the third period. Left to right is third period, okay? Okay, so all the atoms, all the Bohr-Rutherfords and the Lewis dot diagrams we're doing, they are neutral. Protons are equal to the number of electrons. Well, what happens if you have more protons than electrons? Well, they're no longer equal. If you have more protons are positive, electrons are negative. If I have 5 protons and I have 5 electrons, it's neutral. But if I have 5 protons and 4 electrons, that means I have 1 more proton. That means I'm more what? Positive or negative? The answer is positive because protons are positive. So why would you have a different amount of protons than electrons? Well, the answer is because it wants to become stable. Now, protons are in the middle of an atom, right? And electrons are on the outside, so you'll never lose a proton. Electrons can move, protons cannot. Electrons can be lost or they can be gained. If I lose an electron, that means I have more protons, and protons are positive, so therefore I'm positive. So if I lose an electron, I become positive. If I gain an electron, I'm going to be negative because electrons are negative. So gaining electrons means I'm negative. Losing electrons means I'm positive. Okay, let's look at the valence level or valence shell for nitrogen. We know it has 7 protons and 7 neutrons, and we know the outermost shell or orbit is known as the valence level. And how many valence electrons does it have? Well, the answer is it has 5. Good stuff. So in order for this to, right now it's neutral, it's got 7 pluses, 7 protons, it's got 7 electrons, but it's actually not neutral at this point. So it's got 7 P's and it's got electrons, it's got 7. So it's neutral. 7 pluses, 7 negatives. Neutrons don't have any charge. But it's not stable. To become stable, it has to have a full shell. So the question that I have for you is what is this going to do to get a full shell? Is it going to lose or gain electrons to get a full shell in the outermost level? Well, the answer is it's going to, if it has more than 4, it's going to gain electrons. If it has less than 4, it's going to lose electrons. So if you have 1, 2, or 3 electrons, we're going to find out that it's going to lose electrons or donate them. If you have more than 4, you're going to gain electrons. Now, why is that? Well, it's because it's easier. If we take a look at this, I could lose 1, 2, 3, 4, 5 and have a full shell. This would be my full shell, those 2 there. Or I could gain 3. What's easier? Well, the answer is it's gaining 3 is easier. So this atom is neutral, but it's not stable. It's not stable because it doesn't have a full shell. So to be stable, you have to have a full shell. So nitrogen's actually going to gain 3 electrons, and when it does that, it becomes stable. Now, is it neutral now? Well, the answer is no, it's not. It's not neutral. It's actually, let me just clear this out here so you can see, it's not neutral. It's actually not neutral because it has 10 electrons and 7 protons. So what does it have more of, electrons or protons? It has more electrons. How many more? Well, 3 more. So this charge of the nitrogen atom is 3 negative. Okay, what about beryllium? Well, beryllium, it actually has 2 numbers as well. Its 2 numbers are 4 and 9 from the periodic table. This means it's got 4 protons, and that's equal to the electrons. That's why it's got 2 in the first one, 2 in the next one. Well, so I'm going to put my protons in here. And how many neutrons does it have? Well, you got to subtract these two numbers because you know this is protons plus neutrons. So the answer is 5 here. So that's 4 and 5. Is this neutral right now? Well, yeah, it is, because it says right here. It says right here it's neutral. It's neutral because you have the same amount of protons as electrons. They're equal. Is it stable? No. It's not stable. Not stable. Why is it not stable? It's not stable because it does not have a full shell. So what's this going to do? Gain or lose electrons? Well, one thing that this could do is you could gain a whole bunch of electrons around here until I get to 8. I'd have to add 6 to get to 8. Or what I could do is I could actually just get rid of these. And if I get rid of these, I have a full shell underneath that first shell, which holds 2. What's easier? Well, the answer is losing 2. So if you lose 2 electrons, what's our new count? Well, our new count is 2 electrons, 4 protons. What are we? We are going to be positive, and we're positive 2. So beryllium is positive 2. And the valence shell is full. That's it for today's lesson. What I'd like you to do is take a look at the few questions that I have for you. Come see me for those questions, or follow the video for the questions and see if you can answer them to see if you understand. Thanks so much.